So you have entered the correct input, but the system is not accepting the input. That is the first one of the fault that you have with respect to the input. You have the case already and you are repeating the case again. So that's what I will call it as a duplicating the cases. Parenthesis has got the highest priority. If you miss out any parenthesis, it leads to an error. Hello everyone, I welcome all of you to the yet another important and interesting session on software testing. So my dear students, hope you have seen the previous videos. So before you watch this video, I recommend all of you to go back to the previous videos and check what is that I have done in my last classes. So alright, suppose if you have not yet subscribed to the channel, please do subscribe, click on the bell button below because you will be missing out a lot of important notifications on a lot of important sessions. And also, please don't forget to click on the like button because that is the inspiration for me. Alright, so moving on to the first important thing that I have in this session, that is agenda. What is that I'm going to discuss in this session? So please make a note of it. I will be discussing something called specification based testing versus code based testing. So how exactly I need specification based testing and what exactly I'll be doing with the code based testing. I have already discussed that in detail in my previous session, but which one is more important is what I will be discussing in this topic. And the next one that I have is errors and fault taxonomy. What exactly it is? So I will be introducing you all to the different types of faults and errors that we will be coming across. So that's what I will be calling it as errors and fault taxonomy. And the next one that I have is levels of testing. This is going to be very interesting, very important, and the basic thing that we all should know before we getting into the topic called software testing. Alright, this is the day and this is the topic for all of us. Let's start with the first one. Before that, let me give you a small recap till now. What is that I have done and what you should know. So I think I started with the first concept, that is basic definitions. So hope all of you have got introduced to the basic definitions. Like you have got to know about the errors, you have got to know what is faults, you have got to know what is incidents, all those things probably you would have studied by now. So then after the basic definition, I have introduced you all to the concept of test cases. So what is test cases? So this is the two topics that we have discussed in the session 1, but in the session 2 I have discussed something very important, that is Venn diagram. So we have used and we have studied why do we use Venn diagram and how exactly Venn diagram is helping us in testing. So that is what I have discussed with respect to the Venn diagram. So fine. Then after that, using this Venn diagram, we have come to a topic called how do we identify the test cases. So for that, I have discussed two important topics. So two important methods, in fact, to identify the test case, that is specification based testing and code based testing. So that's what you need to understand. So identifying the test cases, with two methods. One is specification based testing, another one is code based testing. So this is what you should know by now. So moving on to the important topic, let's start the class with this. So a lot of people come in and a lot of people debate, a lot of people argue. So which one is best? Whether should I have the specification based testing or should I have the code based testing? Which one has got more advantage? Should I have the specification based testing because I will be testing with the help of the specification? Or should I have the code based testing because I will have the complete idea how exactly program source code is built, so that I will be able to see that which one has got more advantage. So that is the debate that a lot of people are doing it. So that's what I have it here. My dear students, so please listen to me carefully. So each method has got its own advantages. I cannot leave specification based testing and I cannot only depend on code based testing, or in the other way around, I cannot have only code based and I cannot skip the specification based. Both are very important. If I have both the specification based testing as well as the code based testing, I will be able to do my testing very accurately when I compare without missing any of the consequences. That's what you need to remember, and it's very important that to have both specification based testing as well as code based testing. So why do you recommend both the things here? Because you need to remember, you should never forget, specification based testing is completely dependent only on the specification. So you will not have anything which is related to the implementation. So I will not have any idea about the implementation. I will have only specification, whatever the clients have given as a specification or the requirement, only that information I will have it in the specification. But when it comes to code based, I will have the implementation details. So some of the things which is not been specified in the specification also I would have implemented. So all those informations I will have it in the code based testing. So that is the reason, please understand, it's very important to have both the things. So that is what you need to understand at this point of time. So fine. So you all understood that both the things are required to have a proper testing methods. Alright, it's very important to have both the things to have to identify the test cases. So fine, moving on to the next important things. What exactly the next topic that I have? The next topic that I have is errors and fault taxonomy. So you all know what exactly the error is all about and what exactly the fault is all about. What exactly taxonomy is all about. So please understand taxonomy in the sense classification. So what is that I'm trying to classify? I'm trying to classify the faults. I have different types of errors and faults. That is what I'm trying to classify, and I would like to introduce you all how many different types of faults we will come across, or how many types of errors that we will come across. So I have listed out the different types of faults and errors that we will come across. The first one that we have is input-output faults. The first one that we have is input-output faults, and the second one that we have is logic faults. And the third one that we have is computation faults, interface and data faults. This is the 5 different types of faults that we will come across. Sir, what exactly input and output faults? Let me show you about the input and output faults. So listen to me carefully. When it comes to the input, I will come across with the different types of faults. The first one that you can observe here is correct input not accepted. So you have entered the correct input, but the system is not accepting the input. That is the first one of the fault that you have with respect to the input. So what is the next scenario that you can expect with respect to the fault? So you have entered the incorrect input and it is accepted. The system is accepting the incorrect input. So that is the second fault that you can observe. Or the next one that we have, description wrong or missing. You have not given the description at all, so it is missing. So that is the next one that you have. And the parameters wrong or missing. You have not given the parameters at all. So the input in the sense what you have to pass the parameters to make the function work properly, or the system should work properly. You are not entering the required parameters. So that is what you need to remember. That is missing. So that could be one of the fault. So fine, this is a different types of input faults. So what are the different types of output faults that we will come across? So listen to me carefully. So wrong format, you are getting the output, but you are getting the output in a wrong format. So this could be one of the fault. Fine, the second one is wrong result. You are getting the result, but whatever the result that you are getting, it is wrong. So that could be the second scenario with respect to the output fault. So fine, the next one is correct result at the wrong time. Say for example, you are going to the ATM machine and you are withdrawing the money. All right. So your balance, what you had before you withdraw is 5,000. Even after withdrawing the money, I repeat, even after withdrawing the money, still your balance says it is 5,000. Again, you will withdraw. So what is the thing going to happen? So you can withdraw the money again, right? 5,000, 5,000, 10,000 you have withdrawn, but you had only 5,000. After withdrawing 10,000, you are getting a message saying that your balance is 0. So that's what you need to remember here. Correct result, but wrong time. So that's what you need to understand. Incomplete or missing result. You're getting a result, but the result is not complete. That's what I will call it as a incomplete or missing result. Then I have superstitious result. What is this superstitious result? Superstitious in the sense fake result, false result. So that is what they have named it as superstitious result. So fine. Then the next one is spelling or grammar mistakes, whatever you are getting in the output. So that could be one of the fault. And the last one that we have is cosmetic. Cosmetic in the sense how exactly you have formatted. So the visibility or the representation of the output. So that could be a mistake. There could be a mistake in that. So that is what I will call it as a cosmetic, the appearance. All right. So that is what I will call it as a one of the last fault that I have with respect to the output. All right. So by now you would have got an idea that what is that I'm speaking. So I'm speaking with respect to the different types of faults that you should be aware whenever you are testing. So you should be able to test all this criteria, all these fields. All right. So please stay tuned. I have the next fault, that is logic fault. Whenever I have the logic faults, I will be coming across with all these things. The first one that I have is missing cases. There is no case at all. So I have missed some of the cases. That could be the first one. And the next one that I have is duplicate cases. You have the case already and you are repeating the case again. So that's what I will call it as a duplicating the cases. And the next one that I have is extreme condition is neglected. So the main part of the logic, so you have neglected, that is not there in your logic. Say for example, I have a software. Okay, so let me consider that as a birth and death registration system. When it is in the registration system, like in that I have to generate the certificates, death certificate I have to generate. So there I have to enter the date and I have to generate. All right. Suppose if I can generate the death certificate for the next week, then my system is not working properly. That is the main logic. So how can you forget to validate the date? Yes or no? So here in the same way, extreme condition is neglected. All right. So fine. I have misinterpretation. You have not interpreted properly. So that is what I will call it as a misinterpretation. So that could be one of the logical fault that we have. And the next one is missing condition. You have missed out with some of the condition. So that could be one of the logical fault. In the same way, I have testing extraneous condition. You have more conditions. All right. So that is one of the thing. And testing wrong variables. So you have taken the wrong variables. You are testing the wrong variables instead of testing it in a proper variable. That could be one of the logical fault. And the last two faults, that is incorrect loop iteration. You're supposed to execute only 5 iterations, but it is executing for 10. So that could be one of the fault. All right. The same way, wrong operator. Instead of using greater than, so you are using the less than. If instead of using greater than equal to, you're just using greater than. So that could be the wrong operator. So all these cases, one by one, whenever you're checking for the logic, you have to check. So this could be the faults that you will come across with respect to the logic. Sir, is this only the logical faults that I will come across? No, it depends on the system what you are testing. But you have to be a little extra, you have to take a little extra care on this also, is what I would like to mention at this point of time. All right. So the next one that I have is computational faults. What exactly the faults that I will occur whenever I'm computing something? The first one that I have is incorrect algorithm. What is the main thing that I should have for computation? Obviously the algorithm. So if the algorithm itself is not proper, then how will I yield the proper result? So this could be one of the fault that you will come across. And the second one is missing computation. You have to perform, you have to compute something, but my dear students, that computational part is missing. then how do you expect the system to perform that operation? So this is one thing that you need to remember. And incorrect operands. What is operands? Say for example, A plus B. So here what do you call as operand? So this is what I will call it as an operand. This is what I will call it as an operand. And this is what I will call it as an operator. Yes or no? Alright. So incorrect operands. You're not using the proper operands. So that could be one of the computational fault. And the next one is incorrect operation. Instead of performing addition, you are performing subtraction, or instead of performing modulus operation, you are performing something else. All right, that could be one of the fault in the computational part. And then moving on to the next one, parenthesis error. You have not given the proper parenthesis, because you all know the computational will happen based on the operator precedence. So parenthesis has got the highest priority. If you miss out any parenthesis, it leads to an error. So that's what you need to remember, because execution always, the highest priority always goes to the parenthesis. So please keep that in mind. All right, insufficient precision. Say for example, I have to give you the salary. All right. Imagine your salary is like 1000.9.55555555. It goes on precision. All right. Suppose if I don't give 9.55555, the precision, that's what I will call it as a precision. Suppose if I don't have the proper number, then I will not be able to tell you the exact amount. What is that I have to give you? Imagine I'm just ignoring 9.55 all the months. After 10 years, what is the amount that I have to pay you? So that is a loss to you, right? Just imagine I have 1000 employees. If I'm just avoiding this precision, what will be the loss to the employees? What is the profit to the company? So you just need to think about it. All right. So that's what I will call it as a truncation. So how exactly I will round off the precision value? That's what I will call it as a truncation. That's what you need to remember here. And the next one that I have is wrong built-in function. Wrong built-in function. I am using a lot of built-in functions, right? So you guys would have come across with what exactly the built-in functions. Whenever I'm using any platform or any programming languages, so all the languages supports with the rich library functions. What exactly the library functions is all about? Say for example, you have power, okay, which will help me to calculate the power of two numbers. All right, so I have square root, I have max, I have ceil, floor. Already you would have come across with all these functions. What do you call this as? All this is a built-in function. I don't have to write any code for that. It is already there in the standard library. I'm just using it. But when it comes to that, built-in functions, if there is any mistake in that built-in function, obviously I will end with a mistake. So that is what you need to remember. And it comes to the computational facts. All right. Moving on to the next one, that is interface faults. What exactly interface faults is all about? So you all know that the graphical user interface, okay, which comes between the user and the system. So that's what I will call it as the interface. So when I am using the interface, I will also come across with a lot of faults. Even the interface plays a very important role. So let's check what is the thing that I have to check with respect to the interface. The first one that I have is incorrect interrupt handling. So when it comes to the incorrect interrupt handling, so please understand, we have something called try and catch. We have something called try and catch. Why do we use try and catch? To handle the exceptions. To handle the exceptions. In the same way, we need to handle the, please understand, the interruptions. What exactly interruption is? Since you are performing some action, you are performing some operation. So I will come in between. So you are forced to stop that particular operation. That is what I will call it as an interrupt. That is what I will call it as an interrupt. So how exactly I'm able to handle that is what I will call it as an interrupt handling. So I will not be able to handle that interrupt handling. So that's what I will call it as incorrect. So it is not handling it properly. That's what I will call it as an incorrect interrupt handling. So fine. Input output timing. So it is not giving me the input and output in the proper time. And the next one is call to the wrong procedure. Say for example, I will press a button called login. What it should do, so it should help me to log in with the help of the credentials whatever I have entered. So that credentials should go to the database and it should match with the database. So if the credentials are satisfying, or if it is matching, then it should redirect it to the home page. But imagine, instead of calling that procedure, if I click on the login button, it should delete. No, if it deletes your Facebook account, what happens? That's what I will call it as a call to the wrong procedure. For procedure in the sense what? Function. All right. So that's what you need to remember. Call to the non-existent procedures. What exactly it means? You are trying to call a procedure which is not there. You are pressing a login, all right, but I have not coded what should happen if you press on the login button. So that's what I will call it as a call to the non-existence procedure. That's what you need to remember here. And the next one is parameter mismatch. The number of types and the number, parameter mismatch. Say for example, I have a function. For that function, I have to pass two parameters. One is of type int, another one is of type float. Say for example, I have int. All right, int add. So for this function, I need int a comma float b. All right. So how many parameters I have to pass to call this function? Say for example, I have to pass like this, 10 comma 10.35. All right. So this is how I call this function, right? So I have the integer as well as I have the float. So please observe here. When I have this is the correct way of passing the parameters. Imagine instead of having 10, I will have 10.5. So I am not matching with this parameters. So here I'm supposed to have integer, but I have float. It's not matching. So that is what I will call it as a parameter mismatch. So I have here I have two parameters. Instead of 2, if I have 3, then again it is mismatch. That's what you need to remember. Fine. Incompatible types. A lot of data types are there. So some of the types will not be compatible. So there also I will get an error. And the last one that I have is superfluous inclusion. What exactly it is? Unnecessary inclusion. So superfluous in the sense what? Unnecessary inclusion. If you have that, even that will also lead to some of the interface faults. So guys, the last fault that I have is data fault. What will be the faults that you will come across with respect to the data? So fine, the first one is incorrect initialization. Say I have a variable, I have taken a variable, say for example, let me tell you an example like this so that you will understand. So I have the variable and this is what I will call it as the initialization. Say for example, I've taken a variable called height. So if I enter the height as 25 for a human being, so 25 feet, will it be a valid data? No, obviously, right? So that's what I will call it as the incorrect initialization. Alright, I'm not initializing it properly. So fine. Incorrect storage or access. Whenever you are storing the data, you are not storing it properly or you're not accessing it properly. That could be one of the problem with respect to the data faults. And the next one that I have is wrong index value. Why do I need the index value here? When I have stored the data in some place, I need obviously the index to access the data. If I don't have the index value, then it will be very difficult for me to identify where exactly I have stored my data. So that is very important that all of you should understand that. So if I have the wrong index value, say for example, you have drunken and you are not able to go to your house because you don't know the address. Instead of going to your house, you are going somewhere else, to somebody's house. All right, that's what I will call it as a wrong index value. All right, that's what you need to remember. And wrong variables, you are defining the wrong variables. All right, that could be one of the problem with the data faults. And then the next one is wrong data references. You're having a wrong data references and then scaling incorrect types. Say for example, incorrect type in the sense what? When it comes to incorrect types, say for example, I have the salary. So when it comes to the salary, I should have the data type as float because I need to store the accurate result. So instead of that, so you are using the date. You are using the date type. All right. So the data type is not matching with whatever the data that you are trying to store. So that you need to observe here, incorrect type. All right. And I have scaling. So how much I should store? So that's what you need to remember with respect to the scaling. Fine. Sensor data out of limit. So sensor data in the sense what? Even the camera, whatever I'm saying now. So even that camera is also treated as one of the sensor. All right. That will be generating a data and which is of out of limit. Say for example, if it is generating 100 GB, okay, instead of 100 GB, if it is generating 200 GB, it's out of limit. So that could be one of the fault. And the last one is inconsistent data. Last one is inconsistent data. Say for example, I'll ask you the date of birth. So most of you will tell me like, you will tell me the date of birth in terms of number. I'll ask her. You tell me your date of birth. I'll ask Abhishek. Abhishek will say that 21 years old. I'll ask the next person. He will say that 005 or 051 1991. So the next guy I will ask. So what is your date of birth? He will say 1995 0704. Okay. So observe these data. Somebody is saying in terms of year. Somebody is saying in terms of DD, MM, YY. In somebody is saying in terms of YY. DD, MM. So different data, but data is same but in a different format. So there I lose out my consistency. So that is what I will call it as the inconsistent data. So guys, this is a different types of faults that you can come across. All right. Whenever you are testing, you need to keep all these things in your mind and you need to test the software is what I would like to tell you at this point of time. So fine. The next important concept and the last concept for the day. What is that I have? Levels of testing. Whenever I say levels of testing, please understand there is a confusion to most of you. We have levels of testing. Okay, levels of testing is different and types of testing is different. So the other day in the last session, you told we have white box testing and black box testing, and that's not there here. So my dear students, that comes under the concept of types of testing. But this is levels of testing. Don't get confused. When it comes to the levels of testing, so please observe whatever you have in this part. Okay. So this part, so this is what I will call it as a software development life cycle. So whatever the steps that you are able to see here in this side, so this is software development life cycle, but whatever you are able to see this, okay, this is what I will call it as a software testing life cycle. Okay, this is SDLC and that is STLC. So it is coming in a V shape. That's why we call it as a V model. So how exactly it is coming in a V shape? So each step is related to one particular testing. So the corresponding testing. How exactly it is? What exactly that I have here? So can you speak about it? Listen to me carefully. This is one of the interesting topic that all of us should know. The first one that I have is requirement analysis. What exactly requirement analysis? Imagine I need to develop a software. So for that, what is the first step? I need to correct or I need to collect the information that I will call it as a requirements from the clients. So fine, I have collected all the information or all the requirement from the clients. That is what I will call it as a specifications. So fine, is it feasible for me? Can I do it? Is it possible to do it? So that is what I will call it as a requirement analysis. That is what I will call it as a requirement analysis. So fine. Then after that, I have the next stage, that is high level design. What is that I have? High level design. I will be preparing a design of the entire system. I will be preparing the design of the entire system, entire software. So that is what I will call it as a high level design, and the abstraction here will be more. What exactly the abstraction in the sense? Why are you using that word abstraction in the sense? You will not have more detail, you will not get complete depth detail in the high level design. But when it comes to the low level design, say for example, I have the software. That software is divided into separate modules. So each module, so you will have the complete detailed design in the low level design. That's what you need to understand. Say for example, if you ask me to give an example, when it comes to the high level design, I'll give you the bike. So this is how your bike is. But when it comes to low level design, I will speak about the speciality of your petrol tank. I'll speak about how exactly the seat is made, I'll speak about the tire, the size of the tire. I'll speak about the capacity of the engine in detail with respect to each and every spare parts. So that is what I will call it as a low level design. So fine, after having a design, I will start using this design to complete or to start implementing that with the help of the programming. So that's what I will call it as a coding. So fine, you understood the software development life cycle, but you need to understand it's very important. So the other side of testing. So fine, what type of testing that I will be using for low level design? I will be using the unit testing. Unit testing is used to test all the individual modules, whether it is working fine or not. So that is what you need to understand. It will test individually all the modules, whatever I have. If I say modules, so it's an independent modules. It is not dependent on any other modules. Modules in the sense a sub part or a sub program is what I would like to call it. That's what you need to remember here. I will be individually testing each and every modules with the help of the concept called unit testing. So units in the sense small individual units. So fine. Moving forward, I have tested all the small modules. Now fine, I am done with all the small modules. Now what I will do is I will start integrating it. So fine, I have module 1 and I have module 2. So fine, what happens now? Module 1 is tested and it is correct. Module 2 is tested, it is correct. Module 3 is tested, it is correct. Now what I will do? I will integrate, I will join module 1 and module 2. Now after this, will I get any error? So that is what I have to check. So that I will call it as a integration testing. After that, I have combined module 1 and 2. Now it is working fine. I have done the integration testing. Then after that, module 1 and 2 plus module 3, I will add now again. So I will check one more time. So that is what I will call it as the integration testing. So that's what you need to remember. Then fine, after integrating all the modules, I will check, I will test for all the modules which is already combined. The entire system I will test. So that is what I will call it as a system testing. That's what I will call it as a system testing. System testing should satisfy all the requirements which is given in the requirements. That's what you need to understand. This is what I will call it as a levels of testing. This is what I will call it as a levels of testing. So guys, so by this, I have come to an end of this session. So if you want to know more or interesting topics, so keep watching or keep waiting for my next session. So don't forget to click on the like button if you have watched this video. Thank you everybody. Take care of yourself.